Today we're going to be solving trig equations. Here are the things that you need to be able to do. You need to know your trig values that we've been working on. I've been trying to drill in your little brain since December. Your inverse values from last week. You need to know how to handle fractions from 4th grade, square roots from 6th grade, factoring from Algebra 1, and solving equations since before Algebra 1, all of which we have gone over a bazillion times. And I am done reteaching you factoring and fractions and all that stuff. It's time to be big boys and girls and figure it out, because there's way more important things that we have to focus on in here, like the intervals of this, what the trig, how we use it. That's what your focus really should be. Now, one thing that you haven't seen yet, I don't think anyway, is how we square trig functions. So if I have cosine of x and I square it, I don't leave it like that. It doesn't look like that. That's where you get cosine squared x. Okay, the squared goes on the cosine part. Okay, so you pretty much never see it like that unless you're showing your work and you're going to square both sides or something like that. Okay, so let's look at what it's asking us to do here. It says to graph the function f of x equals sine x below, which we've done this a million times, so we should be able to do this just fine. I have a 0 at 0, a 0 at pi, a 0 at 2 pi. At pi halves, I'm at 1, and at 3 pi halves, I'm at negative 1. And then you can just sketch in your graph. Something like that. But curvier and better than what I did. Okay. Actually, I'm going to try and redo it, but it's probably going to look just as bad, but I'm going to try. I think that might be worse, so I'm going to give up and leave it at that. All right. So it says, give the solutions to the equation sine of x equals 1/2 on the interval 0 to 2 pi. So it says, give the solutions. That's plural, so that implies there is more than one. Of the equation sine of x equals 1/2. Well, if the sine of x equals 1/2, then x equals the sine inverse of 1/2, which is the inverse values that we did. So the sine inverse of 1/2 is what? Pi sixths, right? It's pi sixths. So just straight up inverse wise is pi sixths. But one of the differences when we're solving equations is we are on the interval from 0 to 2 pi. So here at 1/2, this is about pi 6. Well, no, it's not about pi 6. It is pi 6. So if the y value is 1/2, the angle is pi 6. Between 0 and 2 pi, am I going to get a sine value of 1/2 any more than just here? Don't I get it here? Right? And here, this is between pi halves and pi, which means it's in the second quadrant, because we know sine is positive in the second quadrant. So my answers are actually pi 6 and 5 pi 6. So you're going to use the generic, or not generic, but the actual inverse values that we talked about last week, but then you have to use that to also find more depending on what your interval is. Okay, so this next one says, give the solutions, so again, implies there's more than one, to the same equation on the interval negative infinity to infinity. So from negative infinity to infinity, how many times am I going to have a y value of 1/2? If this keeps going, how many times is it going to hit 1/2? An infinite amount of times, right? So I clearly can't list them all out. But the next time it looks like this is over here, and that's 2 pi away. Since my period is 2 pi, if it happens now, it's going to happen 2 pi later. If it happens here, it's going to happen 2 pi later, right? So then that's when I can say that my answer is pi sixths plus 2 pi n and 5 pi 6 plus 2 pi n. And it's where n is an element of the integers, but I didn't give it a lot of room, so we'll just leave it at that. Okay? Everybody good with that? Okay. So when we solve a trigonometric equation can have one solution, no solution, or several solutions, or an infinite amount of solutions. And that depends on the defined interval. So the interval is very important to us. When you solve an equation, so like if I'm solving an equation that's not a trig equation, my goal is to isolate the variable. That's still our goal, but before we isolate the variable, we have to isolate the trigonometric function. I have to isolate the sine of x or cosine of x or tangent of x or whatever it is. Then I can get x out of it. So your paper looks different than this. Every time I upload what you have in front of you, this is what pops up, and I cannot, it's driving me crazy. I gave up. So yours is correct. Let me just fix mine. This should be from 0 to 2 pi, with a parenthesis, and so should this one. Everything else is fine, but I changed this, and it won't let me change it for some reason. Okay. All right, so it says solve for all values of x on the given interval. So I have 5 cosine of x plus the square root of 2 equals 3 cosine of x. So again, just got to get all my cosine of x's together. I'm not going to move this because it's dangerous to move something that's all by itself, because that's when y'all move it over, lose your equal sign, and make up math. So instead, I'm going to move this. That's going to leave me with the square root of 2 equals then 3 cosine of x minus 5 cosine of x, negative 2 cosine of x. And I am looking for my answers from 0 to 2 pi, so it's going to take up the whole circle. Well, my circle doesn't look like a circle, but it doesn't really matter. All right, trying to get cosine of x by itself. So I'm going to divide by the negative 2, so I get negative square root of 2 over 2 equals cosine of x. So that means that x equals the cosine inverse of negative square root of 2 over 2. All right, which quadrants is cosine negative in? 2 and 3. Cosine is negative in 2 and 3. So I know that the cosine inverse of square root of 2 over 2 is pi fourths. But I need that in the the second and third quadrant. So what is my pi fourths angle in the second quadrant? 3 pi fourths. And then what is my pi fourths angle in the third quadrant? 5 pi fourths. And so here are my two answers. Okay. What questions do you have? Then we good? We're just solving equations. If you know how to solve equations, you know how to do all that, you're going to be just fine. Oh my goodness. All right, 7 secant of y equals secant y minus 4 square roots of 3. So I'm going to have to subtract secant y over to the left, so that'll give me 6 secant y equals negative 4 square root of 3. And again, I'm going from 0 to 2 pi, a whole circle there. All right, so in my equation, what would be the next thing I do? Divide by 6, yes, so I get secant y equals negative 4 square root of 3 over 6. Then that will reduce to negative 2 square root of 3 over 3. Now, when we did the inverse, we didn't talk about cosecant, secant, and cotangent because we don't need to. I mean, you can figure those out if you want to, but really I think it's better to do everything through sine, cosine, and tangent. So once, I can't do it up here, but once I get to this last step here, I can take the reciprocal. What's the reciprocal of secant? Cosine. So the cosine of y is going to equal negative, what's the reciprocal of 2 square root of 3 over 3? You should know it like that. Square root of 3 over 2. All right. Cosine of y is negative. Cosine is negative still in the second and third quadrant. So when I take this, the cosine inverse of square root of 3 over 2, you get pi, it's a pi sixth angle. So what's my second quadrant pi sixth angle? 5 pi sixths. And then my third quadrant, 7 pi sixths. Very good. What questions do you have? Good? All right. So let's look at number 3. I've got 3 tangent of A equals tangent of A minus 2. This time my interval goes from pi to 3 pi halves. So that's just quadrant 3. Okay. So this 3 tangent A equals tangent A minus 2. I'm going to subtract tangent A from both sides, so I get 2 tangent A equals negative 2. So then I'll divide by 2, so I get that the tangent of A is equal to negative 1. That means A equals the tangent inverse of negative 1. Okay. So when is tangent, or what quadrants is tangent negative in? Second and third. So if I'm, no, not second and third. Second and fourth, sorry. I was like, yeah. Tangent is negative in the second and the fourth. It's positive in the third. So if I'm only looking for the third quadrant answers, can I give you an answer for when tangent is negative 1? I can, so my answer is just the empty set. We good with that? Okay, so number 4. 4 sine squared u plus 8 equals 11. So usually when you have a quadratic, you want to set it equal to 0, but that's not how you solve every single one of them, and that's actually not going to help us here, so I'll just tell you that up front. We are going to go from pi to 3 pi halves. So same thing, just third quadrant here. So I have 4 sine squared u plus 8 equals 11. I'm going to subtract 8 from both sides, so I get 4 sine squared u equals 3. Then I would divide by 4, so I get sine squared u equals 3/4. I don't want sine squared u. I want sine of u, so what do? How do you undo the squared? Square root. So I'm going to take the square root of both sides. When I do that, I get the sine of u equals plus or minus the square root of 3 over 2. So that means that u equals the sine inverse of plus or minus square root of 3 over 2. Which means that if I had the whole circle, it'd be every single quadrant. And since it's plus or minus, I know I'm going to get an answer, but in the third quadrant, is sign positive or negative? Negative. Okay. So it doesn't really matter here. I just have to know I get my third quadrant angle. So when sine is square root of 3 over 2, that is a pi thirds angle. What's my third quadrant pi thirds angle? 4 pi thirds. And then you're done. What questions do you have? Okay. All right, so first of all, what does it say up here at the top? Factoring. Solve by factoring. So if you don't know how to factor, this is going to be impossible. I don't know what to tell you. We're going from 0 to 2 pi, so that's the whole circle. And this is a quadratic. It's already set equal to 0. This should be something easy to factor because this is a what? What do you call this? Difference of squares. It is a difference of squares. So that means I'm going to get 2 cosine x plus 1 times 2 cosine x minus 1. And that equals 0. So we actually could have solved this one like we did number 4. But if you don't know how to take the square roots of the fractions and what to do with that, and you don't put plus or minus, you're going to get them all wrong. So it's really safer to factor when you can factor. So now that I have this, to solve these, I set each one of these equal to 0. 2 cosine of x plus 1 equals 0. So that means that 2 cosine of x equals negative 1, and cosine of x equals negative 1/2. All right. So I have the entire circle. What quadrants is cosine negative? Second and third, right? So the cosine inverse of 1/2 is a pi thirds angle. So to solve this here, I need my second and third quadrant pi thirds angles. So that 2 pi thirds and 4 pi thirds. Okay. Then I also need to solve this other one. and that's going to give me 2 cosine x minus 1 equals 0. So 2 cosine x equals negative 1, and cosine x, what did I do? Oh, yes, positive 1. Thank you for stopping me. Cosine x equals 1/2. Just seeing if you're paying attention. Good job, you're paying attention. All right, so cosine is positive in quadrants 1 and 4. So that's still the pi thirds. That's going to give me pi thirds. And what's my fourth quadrant? 5 pi thirds. So once you solve each piece, then you put it all together in order through little squiggly brackets. So it's going to give me pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Okay. What questions do you have? Good? Okay. So cotangent of x equals cotangent x times sine squared x. So that is a quadratic. I need to set it equal to 0. And here I am going from pi to 2 pi. All right, so that gives me 0 equals cotangent x times sine squared x minus cotangent x. Do you see a GCF that I could factor out? Cotangent of x. So 0 equals cotangent x times sine squared x minus 1. Now, can I factor what's in the parentheses? What is that in the parentheses? It is a difference of squares. So I get 0 equals cotangent x times sine x plus 1 times sine x minus 1. So now that it's all factored, I can solve each piece here. So cotangent x equals 0. But remember, we don't want to leave them as the reciprocal functions because that may not be the easiest way to figure them out. So that reciprocal is tangent x, and then the reciprocal of 0 is undefined. So between pi and 2 pi, when is tangent undefined? 3 pi halves. It's also undefined at pi halves, right? But we don't care because it doesn't fall in that range. So x is equal to 3 pi halves. All right. So then I get sine x plus 1 equals 0. So the sine of x equals a negative 1. So between pi and 2 pi, when does sine equal negative 1? 3 pi halves again. So x is equal to 3 pi halves. Then I get sine x minus 1 equals 0. So sine x equals 1. So when does sine equal 1 between pi and 2 pi? It doesn't, because it is at pi halves, and that doesn't help me. So in that interval, it doesn't. Okay. So then when I put all that together, 3 pi halves shows up twice. Do I write it twice? No. I just get 3 pi halves. What questions do you have? Anything? See how we're just putting all this stuff together that we already know how to do? All right, let's look at number 7. 3 pi halves to 2 pi. So that means that's just the fourth quadrant. This is a quadratic, so I want to set it equal to 0, and I want this to be positive, so I'm going to move everything over to the left. So I'm going to get cosecant squared theta. Then I'm going to add cosecant to the left, cosecant theta. I'm going to subtract that 7. So it's going to give me minus 2, and that equals 0. Okay, so that's a very simple quadratic to factor. it's just instead of having x squared plus x minus 2, your x is cosecant theta. Okay? So I'm going to make this into two binomials. They're both going to start with cosecant theta. This is negative, so the signs are opposite, so I have a plus and a minus. So I need two numbers that multiply to give me negative 2 and add to give me a positive 1. Well, it's 1 and 2. Which one's positive? Because this is positive. The 2. And this is 1. Okay? And if you multiply it back together, you get what you had up there. Just pretend like the cosine theta is x. All right, so then I'm going to solve these. Cosecant theta, well, it's going to equal negative 2. You should be able to figure that out by now. And I don't want cosecant, I want sine. So sine theta equals negative 1/2. So is sine negative in the fourth quadrant? Yes, it's negative in the fourth quadrant, so I'll have an answer here then, but it'll just be 1. So the sine inverse of 1/2 is pi 6, but what is my fourth quadrant pi 6th angle? 11 pi 6. Good. So then I solve this one. Cosecant theta equals 1. So sine theta equals 1. When does sine equal 1 in the fourth quadrant? It doesn't. So this is just the empty set. So when we put it all together in the end, we just have one answer. Theta equals 11 pi 6. What questions do you have? All right. Number 8. We're going from 0 to pi. So I have sine x times secant x plus 2 square root of 2 sine x equals square root of 2 sine x. If you have two different trig functions, like we have a sine and a secant or whatever they are, if there's more than one, it's going to be a factoring for sure. So I want to set it equal to 0. So I'm going to move this over to the left. So this is going to give me sine x times secant x. And then I have a positive 2 square roots of 2 of sine x. And then I'm going to subtract square root of 2 sine x. So that just leaves me with square root of 2 sine x equals 0. Do I have a GCF I can factor out here? Sine x. Good. So I have sine of x times secant x plus the square root of 2 that equals 0. So that's all factored, so I'm going to split it up. Start with sine x equals 0. Okay, well between 0 and pi, when is sine 0? Pi is 0, right? 0 and pi. That makes sense? Good. All right, then I have secant x equals negative square root of 2, right? The reciprocal of secant is cosine, so that equals negative square roots of 2, or negative square root of 2 over 2. Between 0 and pi, when is cosine negative? Just in the second quadrant, yes, at 3 pi 4. So it's a pi 4th angle. I need my second quadrant pi 4th angle, just 3 pi 4ths. So x equals 0, 3 pi 4ths, and pi. Okay. Any questions? We all good? All right, then let's look at number 9. All right, so I've got a quartic here. Definitely want to set it equal to 0. And here I'm going to be going from pi to 2 pi. So this is going to give me secant to the 4th x minus 5 secant squared x. Once I subtract that one over, then I'm going to add the 1. That'll give me plus 4 equals 0. So it is a quartic, but it is set up where I can factor it like it's a quadratic, in the same manner anyway. So I'm going to have secant squared x at the beginning of both. This sign, this is positive, so the signs are the same. This is negative, so they're both negative. So I need two numbers that are going to multiply to give me a positive 4 and combine to give me a negative 5. Negative 4 and 1. Okay, or negative 1 and 4, whatever. I'll put the 1 first, it doesn't matter. Now what's in each little parentheses there, can I factor those things? Yes, I can. So this will bring me to secant x plus 1 times secant x minus 1 times secant x plus 4 times secant x minus 4. 2, thank you. Dang it. Yes, you're right. All right, so now that I have that, solve each one of these. So this gives me secant x. Hang on, that blue's too light. It gives me secant x equals negative 1, which means that cosine x equals negative 1. Between pi and 2 pi, when is cosine negative 1? At pi. So then I'm going to get secant x equals 1. So cosine x equals 1. Between pi and 2 pi, when is cosine 1? 2 pi. So then secant x equals negative 2. So cosine x equals negative 1/2. I'm using quadrants 3 and 4. Which quadrant is cosine negative? 3. Okay, so the cosine inverse of 1/2 is pi thirds. So I need my third quadrant pi thirds angle. What's that? 4 pi thirds. Okay. Then secant x equals 2. So cosine x equals 1/2. So that's going to be in the fourth quadrant. So my fourth quadrant pi thirds angle is 5 pi thirds. Then I put all this together. I'm going to start with pi, then 4 pi thirds, then 5 pi thirds, and then 2 pi. Okay. Good? What questions you got? Okie dokie. Last one. So this one is set equal to 0. We are going from 0 to pi. Do you have a question? You sure? Okay. From 0 to pi. It's a cubic. I got 4 terms. What process do we use to factor this? Okay, yes, it is at equal to 0. What do I do now? Grouping. Good. I'm going to group it. So I'm going to group these two together and these two together. Out of these two, I can factor out a tangent squared y. That leaves me with tangent y plus 1. Out of these two, I can factor out a negative 3. That leaves me, oh, I forgot my y. Tangent y plus 1. And that equals 0. So then I've got tangent y plus 1 times tangent squared y minus 3 equals 0. That tangent squared y minus 3, is that a difference of squares? No, so I can't really, I'm not going to factor it that way. Instead, I'm just going to solve these. So this gives me tangent y equals negative 1. So which quadrant, if I'm using quadrants 1 and 2, which quadrant is tangent negative in? 2. And the tangent inverse of 1 is pi 4, so I need my second quadrant pi 4th angle, which is 3 pi 4ths. Okay, so then here I get that tangent squared y equals 3. I don't want tangent squared, I want tangent, so what do? Square root. I'm going to take the square root of both sides, and I'm going to get tangent of y equals plus or minus the square root of 3. So that means I'm going to have a first and a third quadrant angle here. The tangent inverse of the square root of 3 is pi thirds. So I need my first quadrant pi thirds angle, which is pi thirds, and my second one, which is 2 pi thirds. Then I put it all together in order. So I'm going to start with pi thirds, maybe pi thirds. What comes next? 2 pi thirds, and then 3 pi fourths. Okay. What questions do you have? You can do this, or I wouldn't give it to you. You know how to factor, you know how to solve equations. You got this, all right? Your assignment for today is in Delta Math. I want you to get started on it now. You need, even if you don't get it all done today, because it isn't due today, but you should do some of it. Get as much done as you can because it will help you practice for what we're going to do tomorrow, okay?